Good evening, students. Welcome back, and I hope that you all are doing absolutely fine. And you all have revised the last lecture, and I hope that you all have understood the last topic also. But in case if you have any queries related to the last topic or the last lecture, any query you have, then you please text me on my number. Okay. Now let's start with today's topic. Today's topic is characteristics of particles of matter. Okay. The first characteristic for the particles of matter is, the first one is that there are empty spaces between the constituent particles. There are empty spaces between the constituents of particles. It means that particles के बीच में हमेशा कोई ना कोई empty space होती है. कोई भी मैटर, हमेशा हमने किया था लास्ट लेक्चर में, we did that the matter is made up of particles. It is not continuous, it is discontinuous in nature, discrete form में होता है. ठीक है. So that particles are always having empty spaces between them. Okay, and we did an activity on the last lecture that when a tablespoon or teaspoon of a salt is dissolved in water, the volume of liquid almost remains unchanged, है ना. जब हमने एक टीस्पून सॉल्ट का पानी में डाला था तो वॉल्यूम पानी की चेंज नहीं हुई थी. तो दिस इंडिकेट्स दैट पार्टिकल्स ऑफ सॉल्ट गेट्स इनटू द एम्प्टी स्पेसेस बिटवीन द पार्टिकल्स ऑफ वाटर. Okay, as a result we do not observe any noticeable change in the volume, है ना. हमने मार्क लगाया था उस बीकर के ऊपर, तो हमने देखा था कि एक चम्मच सॉल्ट डालने के बाद उस मार्क में कोई चेंज नहीं आया, वाटर का लेवल जितना था उतना ही रहा, है ना. So similarly, and in the activity of potassium permanganate that we did in the last lecture, when potassium permanganate is dissolved in water, the particles of potassium permanganate get evenly distributed in the empty spaces between the particles of water and give a uniform color of the solution, right. So thus we conclude that there are empty spaces between the particles of the matter. These spaces are called interparticle spaces or voids. Okay, so if you have to give evidence for this character of the particles of matter, you can give the same two examples that we have done in the last lecture, that is of potassium permanganate, second one is of salt and water. ठीक है. So the interparticle spaces, जो empty spaces बेटा particles के बीच में होती हैं, they are known as what we call them the empty spaces को क्या बोलते हैं हम, interparticle spaces. We will call them as interparticle spaces, or we can also they can also be named as voids, voids. Clear. Now the next character for the particle nature of matter is, the particles of matter are the particles of matter are continuously moving. This is the second character of particle nature of matter, that the particles of matter are continuously moving. ठीक है. And in this character, if we want to give evidence for this character, if we have to practically explain this character, then we can cast two examples here. First one is, as we know that there is a scientist known as रॉबर्ट ब्राउन, है ना. तो रॉबर्ट ब्राउन ने एक एक्सपेरिमेंट किया था. ही परफॉर्म्ड एन एक्सपेरिमेंट इन हिज लैब. इन दिस एक्सपेरिमेंट he explained the movement of he explained the movement of pollen grains in water. Okay. When he added extremely small pollen grains in water and viewed them from microscope, उसने क्या किया, थोड़े से pollen grains लिए, उसको पानी में डाल दिया, and then he viewed them in powerful microscope. Now what would he observe? What did he observe? He found that these grains were having a rapid zigzag movement. Move on to the next page. I'm just explaining to you what he found. He found that the pollen grains that the pollen grains were having a rapid zigzag movement. उसने फाउंड किया कि पोलन ग्रेन्स को जो हैं वो मूव कर रहे हैं एक जिगजैग पैटर्न में, एक डेफिनेट पैटर्न, रैपिड पैटर्न में, बहुत फास्ट मूव, जैसे दिस इज अ स्लाइड दैट ही saw in the microscope. Suppose this is a pollen grain here, so he saw that it is moving like this, ऐसे, ठीक है, इन दिस रैंडम डायरेक्शन में वो मूव करेगा. सो इट इज द जिगजैग मोशन देखा उसने कि वो मूव कर रहा है. एंड ही एक्सप्लेन्ड द मूवमेंट ऑफ पोलन ग्रेन्स बाय एज्यूमिंग दैट, उसने पोलन ग्रेन की मूवमेंट एक्सप्लेन की, ये एज्यूम किया दैट द पार्टिकल्स ऑफ वाटर are constantly moving in a zigzag manner, and these molecules मतलब water molecules constantly hit the pollen grains, due to which the pollen grains show zigzag motion. Okay, and one thing more, this zigzag motion of pollen grains, the zigzag movement of particles is referred as Brownian movement. Why Brownian movement? Because it is first discovered or noticed by who? Robert Brown. ठीक है, it is first noticed by Robert Brown. That's why it is referred as Brownian movement. Understood? Okay. Now, first example is this, that we can cast in the characteristic that the particles are constantly moving. Second example is very easy, that you can cast, or you can give to explain the motion of the particles, that particles are constantly moving. Suppose we have an incense stick. Hello? Incense stick means incense stick. It means agarbattis. Suppose we have an incense stick, that is agarbattis hai hamare paas. Suppose if we light them in if we lit them in a corner of the room, after some time you will find that what you will find, that the fragrance of these incense sticks is spread in the whole room, in each and every corner. From this activity we can demonstrate that the particles of matter are not stationary but they are moving constantly. Okay, clear? So this happens because of diffusion only. Okay, diffusion also we did it in the previous lecture. It is a, what is diffusion? It's the process of intermixing of particles of different types of matter of their own. Understood? So this is also an example that we can cast in this character, or this activity is also there. And another activity that we can give in this also, you also know that when you add ink in water, when we add ink in water, then what will happen? It is observed that ink starts getting distributed in water, and slowly the whole of water acquires the color of the ink. Suppose ink is of blue color, then the water becomes blue in color. If ink is of red in color, the water becomes red in color. If ink is of green in color, the water becomes green in color. Understood? So this is also because of diffusion, and this is also explains that the particles of matter are not stationary, they are constantly moving. Okay, and it also explains that the particles have the spaces in between them, that is interparticle spaces. Clear? So these are the three examples which you can cast in this character. The particles of matter are continuously moving. If you want to understand it, okay, it is easier to understand this character with help of these examples. Now moving on to next topic. Next character we can say there. The third one is the particles of matter possess kinetic energy. What do you mean by kinetic energy? It is a term of physics only, but it is also used in chemistry. Kinetic energy, beta, it is referred as an amount of, is a type of energy, that is energy possessed by a body. It is defined as the energy possessed by a body due to its motion. कोई भी चीज, anything which is in motion, it always possesses kinetic energy. Learn this thing, please. This is very important. Anything which is in motion, you will discuss this in detail in physics only on the second term, I think. But now, for now only, you have to learn that. You have to cram it or learn it that anything which is in motion, either it is a fan, it is us, our hand when it is in motion, curtains when they are moving with help of air also, dust particles in the air also, vehicles when they are moving, everything in the universe which is moving possess kinetic energy. Okay, the energy possessed by a body due to its motion is known as kinetic energy, as we have done in the second character, that the particles of matter are continuously in motion, and we proved it with the help of some evidences. So we can say that because the particles of matter are continuously moving, so we can say that they possess kinetic energy. And one thing more which is very much important to do in this character, that the kinetic energy, I am referring it by Ke only, kinetic energy, please understood. The kinetic energy always directly proportional to the temperature. In case of particles of matter, the kinetic energy of particles is directly proportional to the temperature. As the temperature increases, the kinetic energy also increases. If we increase the temperature of the system, then the particles of the system becomes more energetic, and their movement become faster. This also results in the higher rate of diffusion. Okay, so we can say that diffusion is also directly proportional to temperature. As the temperature increases, the process of diffusion also increases. How? Suppose we have ink. We have not, don't take the example of ink because it is easily soluble in water. Suppose take an example of copper sulfate. There is a substance available in the lab or salt available in the lab, that is copper sulfate, and if we add it in water, okay, then the water becomes blue color, blue in color. Blue color solution we will obtain if we will add copper sulfate in water. Okay, now if we will add copper sulfate in water, what we will obtain? A blue color solution. Now suppose we have two beakers, beaker 1, beaker 2. Okay, we have added water in this and in this second also. Suppose 50 ml water is in this. Suppose 50 ml water is added in the second beaker. Suppose in the water which we have taken in the first beaker, it is cold water, that is low temperature, and in the second beaker the water we have taken, suppose it is hot water or boiling water. Anything else? Okay. Now what we have to do next? We will add copper sulfate in first and in same time the second beaker also. What you will observe after some time, that the copper sulfate that we have added in the first beaker is remains at the bottom of the container, and the color of solution is not so dark as in case of second beaker. If we add copper sulfate in second beaker now, which is having a hot water, it will spread in a fraction of a time in whole water, and the solution will becomes blue in color. This will also change to the blue color solution, but it will take some time. So we can say that as the temperature is higher in the second beaker में बेटा टेम्परेचर हाई था, इसलिए उसमें डिफ्यूज़न बहुत फास्ट हुई, मतलब कॉपर सल्फेट के पार्टिकल्स वाटर के साथ बहुत जल्दी मिक्स हो गए, पर टेम्परेचर फर्स्ट बेकर में बहुत कम था, इसलिए उसमें डिफ्यूज़न बहुत कम हुई, बहुत जल्दी नहीं हुई, उतने टाइम में नहीं हुई जितने टाइम में जल्दी सेकंड में हो गई. ओके, सो मीन्स क्यों नहीं हुई डिफ्यूज़न जल्दी? बिकॉज काइनेटिक एनर्जी ऑल्सो डिपेंड्स अपॉन टेम्परेचर. जितना टेम्परेचर ज़्यादा होगा बेटा उतनी ही काइनेटिक एनर्जी, उनकी मूवमेंट फास्ट होगी पार्टिकल्स की. और इफ़ द व्हेन द पार्टिकल्स मूव in a very high speed, then the diffusion also occurs at a very high rate. Okay, if the particles of the matter moves at a very high speed, then the diffusion also occurs at a very high rate. So understood? This is about kinetic energy, and this is very much important. You have to keep in mind these two relations, that kinetic energy is always directly proportional to temperature, diffusion is also directly proportional to temperature. As the temperature of a system increases, both kinetic energy as well as diffusion increases. Diffusion increases, why? Because there is an increase in kinetic energy only. ओके, ऐसा नहीं बोलना कि काइनेटिक एनर्जी इंक्रीज कर जाएगी, क्यों? क्योंकि डिफ्यूजन ज़्यादा हो जाएगी, नहीं ऐसे नहीं बोलना. हाँ ऐसे बोल सकते हैं कि डिफ्यूजन ज़्यादा हो जाएगी, क्यों? क्योंकि काइनेटिक एनर्जी इंक्रीज हो जाएगी पार्टिकल्स की. ओके, द रेट ऑफ डिफ्यूजन डिपेंड्स अपॉन काइनेटिक एनर्जी, बट काइनेटिक एनर्जी नॉट डिपेंड्स अपॉन डिफ्यूजन. ओके, सो क्लियर? दिस इज द correct third characteristic of matter. And next, moving on to next character, this is the fourth characteristic of particles of matter. This is that the particles of matter attract each other. मैटर के पार्टिकल्स बेटा हमेशा किसी को क्या करेंगे? अट्रैक्ट करेंगे. द पार्टिकल्स ऑफ मैटर ऑलवेज अट्रैक्ट ईच अदर. ड्यू टू दिस अट्रैक्शन द पार्टिकल्स होल्ड देम टुगेदर इन अ पर्टिकुलर मैटर. ओके, फॉर एग्जांपल, बट द अट्रैक्टिव फोर्स बिटवीन द पार्टिकल्स डिपेंड्स अपॉन मैटर टू मैटर. फॉर एग्जांपल, इफ वी हैव फर्स्ट अ पीस ऑफ आयरन piece we have, suppose, ठीक है. Second, a piece of chalk. Third one is a piece of rubber band or a rubber band. suppose we have three things: iron piece, chalk piece and a rubber band. ठीक है, what we have to do, we have to try to break them with hammer. Suppose we have a hammer at home, or I think all of you have having hammer at the home. You can also try this activity at home, that try to break these three things with hammer. What would you observe? You will observe that the piece of iron is most difficult to break. You know, this is piece of iron is this type, most difficult to break, है ना? But breaking of chalk and rubber band is relatively easier. इन दोनों की breaking बहुत relatively means as compared to the iron piece is very much easier. Okay, this what does this indicates? This indicates that the particles in iron are held together by stronger forces of attraction as compared to the particles in the piece of chalk and in the rubber band. Understood? So we can say that the particles of matter always attract each other, but the force of attraction between the particles vary from matter to matter. Just like in this case, iron piece is having most of we can say that iron piece is having stronger forces of attraction, but the piece of chalk and rubber band are having weaker forces of attraction as compared to the iron piece. Clear? Okay. And one thing more, बिकॉज सम एनर्जी इज नीडेड, है ना? बिकॉज अगर हम हैमर से उसको हिट करेंगे ब्रेक करने के लिए तो हमें एनर्जी चाहिए, हमें कोई एनर्जी होगी तभी हम हिट कर पाएंगे. बिकॉज एनर्जी इज नीडेड टू रिक्वायर द मैटर इन टू पीसेस, टू और मोर पीसेस. ठीक है. सो दिस ऑल्सो इंडिकेट्स दैट द पार्टिकल्स इन मैटर आर हेल्ड टुगेदर बाय स्ट्रॉन्ग अट्रैक्टिव फोर्सेस. Clear? Understood? Okay. So I'm again explaining this character because this is of much importance in the next chapters also. Particles of matter attract each other. It means there are some interparticle forces of attraction in the matter. Okay. For example, we have three things: iron piece, iron nail, chalk piece, rubber band. If we had to break them into pieces, two or more pieces, we have to hit them with a hammer. Suppose we hit them in the hammer one by one. What we will observe? We will observe that the iron piece is most difficult to break as compared to the chalk piece and a rubber band. So from here, what we can understand that the iron piece, in the iron piece, the particles are held together by strong attractive forces as compared to the particles in the piece of chalk and rubber band. And second thing, what we can observe, because energy is needed to break the matter into some pieces, iron piece, chalk piece और rubber band, तीनों को break करने के लिए कोई ना कोई एनर्जी चाहिए हमें. Because energy is needed, so we can conclude, or it indicates that the particles in matter are held by some attractive forces. And one thing more, the strength of these forces depends from one kind of matter to the other. मतलब it varies from one kind of matter to the another. Okay, clear? And this is all about the characteristics of matter. Okay, clear? Okay. Now, moving on to next topic, we have is, this is all about beta characteristics of matter. Moving on to next topic is states of matter. You are quite familiar with it, this topic. Sorry, not hammer. Sorry, matter. ठीक है. States of matter. You are quite familiar with this topic because you did it, I think, in the lower classes also. States of matter. The question, if the question comes in paper, it will come from this topic like this, that what are the different physical states of matter. So we can say that there are three physical states of matter. How many states? Three states of matter, physical states of matter are there. वैसे तो five हैं, otherwise there are five states of matter, but the three are the most common, and we will discuss only these three in detail, and rest of the two we will discuss in brief only. Okay, that is beyond the scope of this class. That's why the three main states are: first one is solid state, the solids; second one is liquids, and the third one is gases. These are the three states of matter, and the rest of the two states, that is, we can say that fourth is plasma, fifth is BEC, Bose-Einstein condensate. Okay, its full form is Bose. I am writing here. E is for Einstein, ENSTEIN. Please remember the spellings of Einstein. EIN, Einstein condensate. Condense से बन गया condensate. We will discuss these two later on, but now we will discuss solids, liquids, and gases in detail. Okay, understood? Now just see it for a while. Done? Now let's discuss first in brief about these three states of matter: solids, liquids, and gases. Solids. In solids, we can say that the constituent particles, because solid is also a type of matter, it is made up of particles only. Particles are closely packed. Okay. First one, we can say that, hence if they are closely packed, hence the interparticle spaces are extremely स्मॉल, बिकॉज स्पेस नहीं होगी ना बेटा उसमें. अगर वो क्लोजली पैक्ड होंगे तो स्पेस बहुत कम होगी. इंटर पार्टिकल स्पेसिस आर एक्सट्रीमली स्मॉल. ओके, थर्ड वन. और क्या क्या कह सकते हैं हम इसमें से? और अगर इंटर पार्टिकल स्पेस कम है, इट मीन्स इंटर पार्टिकल फोर्स ऑफ अट्रैक्शन क्या होगी? वेरी स्ट्रॉन्ग. इंटर पार्टिकल फोर्सेस ऑफ अट्रैक्शन आर वेरी स्ट्रॉन्ग. और कुछ? Due to these three reasons, we can say that solids are defined as, ठीक है, the substances or a matter which have a definite shape and a definite volume. Huh? Suppose this cap I have, this is a cap I have, this is solid in state. Why? Because its shape is definite. If I put it in any container, any bottle, in a jar, anything, and here also it lies, its shape does not change, it will remain same. Its volume also remains same, it will not change. Okay, so we can say that this is solid in state. Okay, so this is a definition also. Because of the three above characteristics of solids, it will become the definition of solid, that the substances which have a definite shape and a definite volume, they are known as solids. Okay, now this is a brief explanation just of solids. I'll give you the डिटेल्ड एक्सप्लेनेशन टुमारो in the next lecture session. ठीक है. Now next about liquids in brief. Liquids as compared to solids, the particles are less closely packed. Particles ज़्यादा closely packed नहीं होते. ठीक है. Second one is we can say that the interparticle force of attraction are not as strong as in solids, है ना. Interparticle forces are not as strong as in solids. Understood? Third one, what we can say, that interparticle spaces are more. I'm not writing here. Interparticle space are more as compared to solids. So from these three characteristics, we can say that liquids are the substances that have a fixed or a definite volume but not a definite shape. This is how we will define liquids in brief. The substances that have a fixed volume but not a definite shape. Clear? Why? Because suppose we have a 1 liter of water, okay, in a bottle. If the water is kept in a bottle, its volume is 1 liter only, and it requires the shape of the bottle. Suppose we have a jug. Suppose we have a jug. It is cylindrical in shape or different shape, is having a much more broader than the bottle, and shape is different. So suppose we put the water which is kept in a bottle, 1 liter bottle, in a jar, transfer it into a jar, glass jar or a jug. Then what will happen? The volume of the water remains same, 1 liter पहले था, अभी 1 liter रहेगा, but the shape of the water क्या होगी? चेंज हो जाएगी, changes. It will acquire the shape of the glass jar in which we now kept the water, or the jug. Anything, any container we have except bottle, it will take the shape of that container. So why its volume is not fixed? Because the interparticular forces of attraction are not so strong, and it has what? It has the interparticle spaces. Okay, clear? That's why we will discuss this in detail also. Just for today's only, I am giving you the brief explanation. And now what about the gases? गैसेस का हमें पता ही है, ठीक है. गैसेस के पार्टिकल्स तो क्लोजली पैक्ड होती नहीं है, ठीक है. दे आर वेरी लूजली पैक्ड. एंड इंटरपार्टिकल स्पेसेस इन गैसेस आर एक्सट्रीमली लार्ज. Interparticular forces of attraction is very less in gases. So from these three characters, we can say that the gases are the substances that neither have fixed shape nor a definite or a fixed. You can use definite word also or a fixed, any one of these two as you like. Definite volume, जिनकी ना तो फिक्स कोई शेप होती है ना वॉल्यूम होती है, they are known as gases. Suppose we have a gas in a cylinder. If suppose it leaks out, it will क्या होगा? वो फैल जाएगी, पूरे रूम में फैल जाएगी, and it will take the shape of the room also, and वॉल्यूम भी उसकी क्या होगी? इंक्रीज होगी. अभी पहले वो छोटे से सिलेंडर में थी, अभी वो पूरे रूम में है. अंडरस्टूड? ठीक है. सो गैसेस neither possess a definite shape nor a definite volume. So we will discuss the rest of chapter in next lecture. That's all for the today. Please do the assignments on your fair notebooks. The questions I am sending you on the fair notebooks, and please do revise the chapter thoroughly. from your books. ठीक है, okay. I am also sending you the photos of these notes in the group, so please do revise them. If you have any queries related to this topic or any other, you can please text me. So, okay, bye bye, take care.